always been said, don't eat burgers, pizzas, junk foods, all unhealthy and causes cancer, etc., etc. But have you ever wondered the current era that we're living in, eating vegetables, fruits that are even natural can be deadly? So, according to the United Nations, approximately 200,000 people die every year due to pesticide poisoning, and around one third of the fertilizers end up in landfills, poisoning the environment rather than benefiting us. So, basically, what we are eating itself is a poison. And what's the purpose in eating healthy? What is the purpose in eating fruits and vegetables? So, what we require is sustainable agriculture and organic agriculture. In that case, what does this mean is growing vegetables and fruits without any pesticides and fertilizers. But there are quite major problems. Either they're not effective enough or they're way too expensive, such as hydroponics. So, in recent studies, like in the University of Berkeley, California University, and Harvard University, they come up with a new technology called electroculture. Basically, electroculture is a new form of system or a process via which we can grow plants more productively with higher yield. The fact is, it is actually not a new process. It has been a historical significance to the 18th century itself. It has been discovered, but has not grown to a large potential. But still, we are not yet fully understanding what exactly and how exactly electroculture works. But as a very much enthusiastic student in science, I decided to do a project on it. So in the coming month, in November, there is a competition happening in PSG, College of Technology, called YES, Young Environmental Scientist Competition. Basically, I'm enrolled myself into it as a single participant and candidate. So I have decided to do that as my project, and this is introductory to what I have been doing and what are the progress that I have attained over the course of a month. So the entire project is basically you give electricity to roots of the plant, and hence the plant's roots get more stimulated, the pores open more, the more nutrients go in, more ions are present, and hence the larger the productivity, larger the yield, more sustainable it is. There is no use of chemicals, no use of fertilizers, no use of pesticides, hence even good for us, good for the environment, and it is a win-win. And the initial investment is the only thing is required, whereas the entire system has extremely low maintenance, and it is a great alternative to the current sustainable agriculture and pesticide and fertilizer free agriculture alternative that is present in the current era. So basically, this is the entire circuit of the project EcoPulse. So it looks pretty complicated and clustered, but it isn't. It is not too complicated enough. So first, the entirety of this circuit is controlled by this tiny board here. If anyone recognizes, it's nothing but an ESP32. What it does is, it's like a tiny human brain. What human brain does is think and control input and output. Does this tiny thing here does the exact same thing, but for electronics. For example, it controls the output of these motors and takes the input of temperature, humidity, etc. So this is the tiny brain and the thing that is responsible for thought and processing and entirely. And it has the ability to connect to Wi-Fi and as well as Bluetooth. Coming here, this thing is called DHT11 sensor. Its purpose is to collect temperature and humidity data. Here, this is the MQ4 sensor, collects the methane concentration. Here, this is soil moisture sensor, basically figures out how much soil moisture is present in a soil. It is required to be inserted into the soil and figures out the soil moisture content. And coming here, this is a power supply. This is a 24-volt power supply that I have been connected to a voltage controller so that I can experiment with the circuit. And here is a driver. What is the requirement of a driver, if you might ask? This ESP32 is a small board and has the ability to get an input and output of only 5 voltage at max, whereas these motors here each has the ability to run up to 24 volts. That is a huge voltage, and it cannot be controlled by ESP32. Hence, if you give this 24 voltage power supply directly to here, it gets fried and the circuit bursts. So what we do, use a driver, and with the help of this driver, what we essentially do is separate these circuits into the two. Basically, these motors are controlled by ESP32, but what this driver does is it's like a valve. Imagine a valve. This is the input. The water comes through this, and here is a valve, and this is the container. So this valve is controlled by this ESP32. The valve requires a very small amount of energy, right, to open the valve. So this ESP32 provides around 3 volts to 5 volts of voltage to this valve and opens it, and this higher pressure water flows across this. But this is not water, voltage. It's an analogy that I use to explain you guys more simply what exactly a driver does. So this is the external components. So the entire project essentially revolves around providing electricity and voltage to the roots and the plants and increasing the productivity. So if you might raise a question where exactly voltage is being provided and is being controlled. So here the software part controls takes the input all from here, gets processed here, and gets transferred, and it comes to a conclusion that X amount of voltage is to be provided to the roots, and hence what it does, it provides a pulse via a pulse width modulation, PWM. So what exactly it is it gives a signal in a base on the form of pulses. So the pulse, it can be of any width. It can be small, it can be big, depending on the voltage. If the voltage is smaller, it will be smaller, the pulse will be smaller. If the voltage is greater, the pulse will be greater. But it won't be as big as this, but it would be in the form of a electrical pulse that you can measure using something called a oscilloscope, electrode oscilloscope. Sure. So I will explain you the voltage provision circuit. So the voltage goes through something called a buck converter. It converts a higher voltage to a lower voltage and goes through something called MOSFET, MOSFET, metal oxide field effect transistor. Okay, metal oxide semiconductor field effect transistor. Just forget the abbreviation and stuff. But what exactly is this? It's like a switch. In a usual physical switch, you turn it on and off like this, right? But this requires a human contact, whereas this guy requires no human contact. You can do it via pulses, like provided by this ESP32. So this guy can control the on-off switch. There is another component that has not yet arrived called a voltage controller. That voltage controller is like a small IC similar to this one. So before we look into the software part of the project, let us see the logo. So this depicts a tree along with its root. Why exactly EcoPulse, you ask? Eco standing for eco ecosystem, and pulse having a direct correlation to electricity. Since the entire project revolves around the concept of electroculture, I have named it EcoPulse. So first I will just show you the gist of what exactly happens behind the scenes. So first, this AI model that I have used Google Colab to make is run, which gives the data to something called a Supabase. I'll explain what it is in a second. And Open API gives the live weather data to Supabase. So what exactly is a Google Colab is that essentially it is a platform that you can use to code and make stuff such as AI models. I'll just show you here. You can see the various coding that has gone into making this. You can see actual with predicted residual plots. There's so many stuff that is beyond the scope of the video. There's too many coding that has no correlation for you to be able to understand it. Just forget it. So just understand that this Google Colab, what happens here is it creates a AI model. It takes the data from the ESP32 that we have talked about earlier, and this Google Colab processes it. And for a given set of environmental conditions and factors, it predicts how much voltage should be given to the plant. So exactly that's the purpose of AI Google Colab. Here, Open Weather API. Basically, Open Weather is a website via which I can get the live updates of weather for a given state, given country, given city. So that is the entire purpose of this. These both are deployed via render and version respectively. So these render and version have a very common usage. So let's take an analogy. So you do some coding. Assume this is a code. You need this code to be published in the form of a website so that you can view it very easily. So what exactly you do? You use something like these websites, render and virtual. Both have the same usage but are very different in the way you can use them. So I have used this website to create an link instead of the entire code. So when I click the link, it basically takes me back to the, it basically shows up like this, EcoPulse AI. You can view this. And when you click the version link, it shows something like this. Here you can see location Avinashi, Tamil Nadu, temperature 22.02. It is in Celsius, 91% of humidity, overcast clouds. Timestamp is nothing, but basically what or when was this exact code was formed or created, and that's the exact purpose of it. It is either in IST or UTC general. So then, moving back, we have something called Supabase. Just imagine all the data is stored in a server, or think like how things like being stored in a garage. Just like that, Supabase is a place where all the data is stored in a server, but it is online. I'll just show you how it looks. So if you see the AI results, these are tables that I have created, and this is Supabase. You can see various columns that are being filled, like temperature, ESP32 value, and the predictions. This all is got from the AI model that we just talked about. The weather by coordinates is the one we just saw that gave all the weather data for a particular city coordinates. So it was very pretty interesting, you know. What really happened was I ordered this module called a Neo GPS tracker for ESP32s. What happened was something went wrong and I wasn't able to really use it and it just got fried. So I really had one choice, either to somehow get this thing back or just forget the GPS part. But I had no other go but to figure out something else, because without GPS I won't be able to figure out the location, right? So I came up with a new idea. I actually read an article about how you can get the location of a device using just your internet. That's pretty interesting, right? So I figured out somehow or the other, and the data that you're currently seeing here is entirely from internet and has no physical hardware GPS connected to the system as we earlier saw. So that is pretty intriguing in my own point of view. Here you can see the various devices. So the plan was to connect two ESP32s, 1 and 2. I'll explain why is that so in a second. Here we can see sensor data, humidity, soil, moisture, MQ4 temperature, percentage, pH level, electroconductivity level, etc. This is just to publish. And flowing back, here we have two ESP32s. So you can see that this is a sensor node and this is a voltage control. Essentially, what are they? So we have I planned to separate them into two. Currently, the current version that I showed you guys was just a prototype at its early stages. So essentially, I'm going to separate ESP32 1 and 2 for a sensor input and a voltage controller output. The sensor input is the one that I showed that takes in the input of these temperature, humidity, etc. The voltage control is the one that controls the voltage, as we earlier saw, and this all should be visually represented and have some means to control it by the user, right? Here is where the mobile app comes in. So I have no coding experience previously, actually, and I have learned a bit of Java, but have no real coding experience of doing websites and apps. But this entire thing was did with the help of a website called lovable.dev. Here dev stands for nothing but development. So this entire app was created just by using normal English words and sentences. That is pretty cool if you ask me. This is called vibe coding, and this is something that everyone shall learn in my aspects. So this is the app. Here you can see the history of the alerts that have been showing. Here I can select the devices, manage the devices here. Here I can select the crop for a particular device. Basically, if this ESP32 sensor is present in a wheat field, I can change it to wheat field, and vice versa. You can see all the data here. If you notice keen enough, you'll say that these are exactly from this table, which is of 50 pages. But the last value, the latest value will be shown here. The same goes for the weather conditions here. Here, currently, I'm working on the charts part here. it is on progress. What here the function of this chart is you can compare the data over the course of 24 hours, 7 days, and 30 days, and you can view it individually or compare various factors like these. Here you can see the voltage that is being supplied to the plant. Here, the AI insights, the AI result that is shown here is displayed here. And AI control, you can do manual control as well as automatic control here. You can talk with AI on like how to grow rice, how to grow wheat in India, and it will give you a detailed analysis. Since the entire AI is not yet done, there is a bit of misunderstanding between the AI, but will be soon sorted out. Here you can see the general settings, and we can log out also. So this entire app is being deployed on something called GitHub. If might many might have heard of it, but won't know the exact usage. So just imagine you do this coding in Figma or whatsoever. Sorry, you do this coding, and you want this code to be altered. So you alter this code, and you alter it. You overcome some bugs. You alter it again. But at the end of the thing, you need to go back to a particular version at a particular time or a particular line. You need to recover. But if you do it in a normal coding or a normal app, you won't be able to recover it. But in case you do it or connect it to GitHub, you have the ability to control the version of the app or code or whatever. So you can trace back every single line of code and you can tell who exactly edited it. And another good feature of GitHub is you will be able to find something called public assistance. You can get help from the public, and they might help you in decoding, debugging the code. So you guys might raise a question on like why are you doing such a complex project involving so much stuff for extra? The entire reason is I'm not doing such a complex project or doing so much stuff or putting so much effort because I want to win the competition. Maybe that's a part of it. The main goal and the reason is to learn, develop myself, and learn skills that will help myself in future, perhaps. And another few skills such as time management, coding, uh, problem solving, patience, etc. The project is has tested me in various ways, and yet I have been trying to overcome every single one of them. Uh, then, if you ask me, doing such projects is pretty helpful. Not just because that you learn coding or do electronic, but it teaches more than this. For example, like instance where I shared my experience, what happened when I lost my GPS. So that is a part of our solving skills. In future, when you face some problem like this, you are required to think on the spot and come up with a solution that is viable enough. And that is a character of a leader. Anyone and everyone can be a great leader when the things are good. A leader is a one who is having the ability to handle things and situations when the things go the other way and become negative. Thank you.